Morning to everyone. Today I am going to present my work synthesis and characterization of graphene oxide and graphene oxide TiO2 nano composite for solar cell and photocatalytic application. For synthesis of GO, I am using a modified Hummus method with a different amount of graphite powder. From this, I have taken 0.75 base gram of graphene oxide mixed with commercial level P25 degrees of TiO2 nano powder with three different ratios. So then the prepared samples are analyzing the structural, optical, morphological composition and dielectric properties. From structural analysis, I have concluded that all the prepared samples are GO. When GO mixed with the TiO2, the GO peaks are disappear, which is due to intercalation of TiO2 nanoparticle. Also, I have calculated the crystallization is around 19.7 nanometer. From FEC micrograph shows that the prepared GO samples are flake-like structure. When GO mixed with TiO2, these flake-like structures are disappeared and it's like a spherical shaped nanoparticle. From EDS, I have confirmed titanium oxide and carbon peaks are presented in the prepared samples. From UV optical absorption studies of GO, it shows that two peaks. The first peak around 240 nanometer correspond to pi to pi star transition with organic molecular carbon bond carbon. Then the second peak around 310 nanometer correspond to N2 pi star transition due to the organic content of carbon bond oxygen. So when GO mixed with TiO2, the optical absorption edge is shifted to blue region. From photoluminescence analysis, and the two peaks corresponds. The first peak corresponds to 410 nanometer, that is pi to pi star transition. The next peak around 450 nanometer correspond to the band gap of the material. So from dielectric studies, I have calculated dielectric constant, dielectric loss, and AC conductivity. So both dielectric constant, dielectric loss for low frequency, it has a highest value, which is due to space charge polarization. So when go for high frequency region, both dielectric constant, dielectric losses reduces, which is due to orientation and ionic polarization. For AC conductivity studies, the material around for S3, it is the highest conductivity, then S4 and then S2 sample, which is due to a short range transmission, opening up charge carriers between the localized states. So thank you.